our schedule today, we will enter new topic about recurrent neural network. Okay. Okay, let's start. So previously we learned about convolution neural network. Convolution neural network is good if your data set have spatial pattern. What is spatial pattern? Spatial pattern means the pattern is defined by the spatial distribution of the data. But in natural language processing, like text, audio, video, most of data is not spatial, but the data is sequential patterns. Yeah, take a look on this sentence. Yeah, the meaning of the sentence is defined by the order or sequence of the word that define the sentence. Okay, in this paragraph, for example, there are 5 sentences. So the meaning of each sentence and paragraph will be defined by the order of the sequence. Okay. Imagine a case you make NLP tasks like machine translation. And imagine a case you make a task about speech recognition. The data is sequential data. In case of machine translation, your input is sequence, your output is sequence. You need something in the middle to define the latent or hidden patterns inside the sequence of the data. Okay, so we can say recurrent neural network is a model, many variant. Initially, we call it recurrent neural network, but now there is more modern architecture like LSTM and GRU. But the task that is solved by this model is input sequence to output sequence, and you want to find the latent variable inside. Okay, so we are talking about working with sequence. In the book, mathematically, you can see the definition of the sequence like features factor X with index or time T. Yeah, sometimes we call it time, sometimes we call it index, but this is just to show the order of the sequence. Okay, so for example, data in stock exchange is a time and value, and there is a patterns inside like time series patterns. Initially, people work with this time series using autoregressive model. Yeah. So autoregressive model like this, latent autoregressive model, it input the sequence of time series and output the next. So it can predict what is the next move of this FTSE 100 index stock. Okay, so it can memorize the patterns. The pattern means the trend of increase or decrease, and also the seasonality of the data and also the noise. Yeah. So sequence model have been studied for maybe 50 years, more than 50 years. And what is the common case now is actually ChatGPT. If you look on ChatGPT, you input a sequence, you expect another sequence in terms of question and answer. And behind ChatGPT, there is language model. What is language model? I will explain later. Okay. So let's start looking on the sequence model as a mathematical equation. Here you can see that the probability of the sequence x1 to xt can be described as a mathematical model, probability of mathematical probability. Okay, but in machine learning, we sometimes employ Markov model. So what is Markov model? In short, for you to get the intuition, I can say Markov model is future is independent of the past given present. I repeat, future is independent of past given present. Here they say future is conditionally independent of the past given the recent history. means that Markov model that the future is not depend on whole history, only on the present history. Okay. If you don't understand Markov model, please try find video in YouTube to explain what is actually Markov model, because many machine learning models is explained using Markov condition. Okay. Okay, let's look on the material. I will use the material from Professor Alex Smola to explain the recurrent neural network. So I mentioned before, we are dealing with the sequence-to-sequence problem. And we say inside the sequence pattern, there is a latent variables. And we want to capture these latent variables, okay? Assuming the input sequence in this picture is X with index T. So we want to find the hidden patterns that map the patterns inside the X, the input, okay? We can say action or explanation as a metaphor or analogy, but let's say machine translation model, you input Indonesian language as an observation and you want to output English, yeah? And there is some explanation actually for the translation from which word goes to which word, and you want to capture that. So you create recurrent neural network with hidden state in green in the color. And this hidden state will update the parameters by training. Yeah. So the hidden state HT is activation C, which is all of this arrow here is the parameters, network parameters, and B is bias. Okay. So you input the observation and you get the output by activating this using this equation. So in recurrent neural net, usually we notate the network with some operation like this. Okay. Okay. So for code, don't worry, you have this one. Okay. You can say make sample data for machine translation from Indonesian to English. Okay. Write PyTorch. You can use library like PyTorch codes to implement recurrent neural net for machine translation using the synthetic data, sample data. Okay. So it will say make a simple machine translation. Yeah. You can open your later with JC. JC will show you how to run this kind of code. Yeah. So make a random. This is the training data set, and you want to make it as a English. Yeah. So of course you cannot put this into neural nets because it's a text. You need to have an embedding. Yeah. So you make sure that what is inputted into the neural network is a factor. Otherwise, you cannot work with it. So in this code, it will give you simple encoder-decoder architecture with RNN, yeah, to perform machine translation. You can learn later on. So I mentioned before, we need to put the raw text and make it as an embedding, factor embedding, yeah. So how we do that? So we load the text into memory and we split the string into tokens. Yeah, let's say you can have a word level tokens. Let's say you have a string of sentence. And then you can make it a word or character level token and you can tokenize it using numerical index. Yeah, the process, we call it tokenization. And there is many library for it. Yeah, for example, your corpus is this, it will give you the tokenization to make sure all words all is unique numbers. Okay, the process is called tokenization. You can read the books later about this tokenization. Okay, And once it's becoming vector, tokenized vector, you can put into RNN and RNN will work for you to make sure you can implement machine translation using simplest RNN. So next I will explain about language model. What is language model? Yeah. So it's a very important concept you have to understand. I will give you the insight. So if I give you a corpus, yeah, corpus is collection of words, building a sentence and paragraph. I give you corpus, yeah. So language model goal is to estimate probability of a sequence based on the corpus. So if I give you a sequence P, x1 to xt, language model will compute the joint probability that this sequence will happen inside your corpus. Okay? So it's a probability estimator. Given a corpus or collection of data, predict, estimate the joint probability of this given sequence. Okay? The technology like ChatGPT is built on large language model. They train the corpus from Wikipedia, from GitHub, from many things. They make many language model with many capabilities like code generation, text summarization, sentiment analysis, and many more. Yeah. So large language model is not only one simple NLP task, but large language model contain large corpus with many downstream capabilities like summarization, uh, code generation, or many more. Okay. But we can make simple language model using recurrent neural nets, yeah, and Markov condition. So let's say I said, this is my language model I want to build, yeah. Okay, let's say P deep learning is fun. So we can compute using this probability, joint probability rules, but we need to have a Markov condition, means that the meaning of deep learning is fun is not depend on everything. It's only depend on recent history. Remember our definition about Markov. Markov condition is future is independent of past given present. Yeah. So not all history it needs. So if I want to compute px1 to 4, I just compute px1, px2, px3, and then I compute px1, x2, x1, x3, x2, x3, x4. Only one step or one window behind for that kind of probability. We call it unigram, bigram, trigram models of Markov. Okay. So you can compute the word frequency as a basis of your probability. You can also perform Laplace smoothing. Perplexity is the measure of how good the quality of language model that you are building. So let me show you. I can make simple language model. So I say make synthetic corpus in English. Write Python code to implement simple language model using RNN, yeah, and test the result of language model. Evaluate and evaluate the language model. Okay. So very simple. I ask very simple prompt. They make me a corpus. Okay. So using this corpus, there is how many words we have to tokenize the corpus. Yeah. So this one is generate a Markov chain approach, making synthetic. And then once it get us have a synthetic sample. And then so this code is actually create the corpus. And this code is creating embedding. tokenize the corpus. Yeah. So this is the algorithm to tokenize the corpus and then make the language model. Okay. Later you can practice together the prompt engineering with JC. Yeah. But in this model is very simple language model. It use nn.rnn. Yeah. With fully connected layer linear. Okay. And then you can test the training completion with this simple prompt. So at that time, we can make simple language model with RNN, very simple RNN, yeah? So RNN is actually a very simple model with this activation, okay? Like I saw you in the slide, okay? So to make a simple RNN, you can just make your corpus embedding, make the embedding, usually using 1/4 encoding for embedding. You count how many unique numbers, unique words, and you make factor, and the size of factor is the size of your corpus. Okay, it's good for corpus that is small corpus, but if the corpus is large, then you will have problem with this model. And after that, you make input the embedded factors into the embedding matrix, and then you can make your language model using this simple model. Okay, this is the summary of the chapter. You have to read the chapter one by one to make sure that you understand what I say. Yeah. So for the concise implementation, of course, there is some optimization inside. Yeah. You define objective function and then you perform and have to compute gradient. So when we learn about convolution neural networks and multi-layer perceptron, we learn about backpropagation. So how we can compute backpropagation if you have time, the notion of time in your input sequence, because the sequence have time t, yeah. So how we can implement that? So in all recurrent neural network, even the modern one like LSTM and GRU, it actually performs backpropagation through time. Okay, so it's the extension of the famous backpropagation algorithm to compute gradient of total loss with the small change of the neural network parameters. Backpropagation through time is a gradient analysis. Is coming from the partial differential or partial calculus by putting the notion of time. It's good if you can learn about how you can understand these things, but in terms of computation using PyTorch is already there. So we are not implementing our own BTTP, backpropagation through time. So it's already given by the library, but it's good if you are a mathematician to understand what is backpropagation through time to compute gradient during the optimization of the RNN. So in this chapter, only that is the only material. You have to understand RNN, simplest form of RNN, making your simple language model and understand truncated backpropagation through time, which is the basis of optimization, gradient-based optimization in recurrent neural nets. Okay, so learn again about this hidden state. Okay, the notation. Take your papers and pencil. Draw the equation of probability, Markov condition, Markov chain. Yeah, to make sure you understand this chapter very well. Yeah, your understanding is very important for prompting. Yeah, so once you understand the topic in terms of fundamental and conceptual, all of the practical code you can prompt, but not the other way around. So this is the best time for you in this Gen AI period to coming back to mathematics. So you can make the coding for codes more trivial. So backpropagation through time is implemented in PyTorch. It's also implemented some autograd, yeah, using backpropagation through time. Usually it implemented as a computational graph in parallel, yeah, in GPU parallelism. You don't have to worry about how to implement those algorithms like automatic gradient through backpropagation through time in PyTorch because it's already implemented by the team who make the PyTorch library. Okay, what we have need to understand is the conceptual and the fundamental of recurrent neural nets. So you can make simple case like machine translation, you can make language model, yeah, you can make sentiment analysis. Let's say in this prompt, I say make synthetic corpus in bahasa in Indonesian language for sentiment analysis, sentiment classification. Okay. Write Python code to implement simple sentiment analysis using RNN and evaluate the accuracy. Because this is classification, you have the label, you need to have a corpus with the label. That will give you the positive words, and it make you a corpus and make you RNN to make your sentiment. But language model like ChatGPT already has this capability. So let's say I make a sentence, okay, sama dengan I hate to learn mathematics, but I love to learn Python, okay? And then I say to ChatGPT, yeah, what is the sentiment of sentence? Okay. I use two words, hate and love, okay? To determine the sentiment, yeah, I hate to learn mathematics, I love to learn, we can analyze sentiment, the word of sentence. Generally, hate has negative, has love has a positive sentiment. Because it's mixed, it can say mixed. So ChatGPT sentiment analysis, it can be more just like classification, yeah? It has more features. It analyzes my word, because if simple classification is confused, which one I use, hate or love, okay? So that conclude that ChatGPT have a downstream capability for sentiment. You can pass any sentence from any article and you can ask what is the sentiment of this. And it already tested with large corpus with ChatGPT, but you can make very simple sentiment analysis model using ChatGPT. There is many tasks in NLP. You can explain common tasks in, I will say, downstream tasks in NLP that already covered by large language. Okay. Text classification, name entity recognition, text generation, text summarization, Q&A, text similarity, semantic analysis, textual entailment, coherence resolution, blah, blah, blah. This is 9 tasks. I believe it's more. Yeah. So how you are looking on that? So you can look on Hugging Face. How many NLP tasks model available in Hugging Face? You can see here, natural language, text classification, token classification, table, question and answer, zero set, blah, 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 blah. I think until now, large language model maybe have a 10 to 100 downstream capability of NLP, okay? But long time back, when I start learning about deep learning, I have to implement my own text classification using RNN. I have to do a token classification or summarization or text generation using generative adversarial network. At that time, this capability is isolated into one specific architecture. But large language model like GPT, Llama, Palm, have combined downstream capabilities that you enjoy so far in the tools like ChatGPT. Okay, that's it from me. So what you have to master or learn deeply after this course is understand the nature of the sequence data and patterns inside NLP context or domain. Second is you have to learn many techniques about how to turn the corpus of raw text into a factor or tokens using many token embedding techniques. Yeah. The most conventional technique is a one-hot encoding. You count any unique number inside the corpus, and then you make a factor as long as at the length of your corpus and give one or zero inside the factor. But of course, it's not the best tokenization. Yeah. For language model, they have many other techniques like back of words or glove or many other tokenization techniques. And then you have to be able to implement your simple RNN using concise implementation in PyTorch, for example. And you have to understand the main algorithm behind for optimization, which is backpropagation through time. The rest you can learn in next chapter in modern recurrent neural nets. Okay, before I hand over to JC, is there any question from you? It's clear? So next week, we will learn about LSTM and GRU. So make sure you learn about this vanilla RNN. No one using it now because it's already replaced by LSTM and GRU and attention and transformer for large language model. But for historical reason, long time back, we need to deal with fixed size of token or factor input, and we have to architect our RNN architecture in every downstream task. But now with transformer and attention, we can deal with many size of corpus. We can make better language model. Okay. So that's it for me. Please continue the practice of prompt engineering for RNN with JC.
Thank you. Let me share my screen first on RNN. Okay, welcome everyone. Welcome to the article system session for prompting on RNN and language models. For this one, we want to try implement like uh, Sir Isman already taught us by making a simple language model. First, if we want to create a language model, we want to have a data set for this uh, try. We are going to create a simple ones because larger ones will take some times to uh, train. So I hope everyone can open their ChatGPT and Google Colab, and so we can start prompting. For first prompt, we want to ask ChatGPT to create patterns or rules for generating text. Uh, I'm sorry. Let's ask GPT to write Python code to create uh, patterns of uh, text to generate another text. Let me see. For RNN model. Let's see. Here they are using defining yourself. Maybe we can ask GPT to define it for us. Text patterns. Find the example. Let's see. Let's see. Let me change the prompt to uh on Python, so the model can learn from it and make. Eh, sorry. So uh, it can it can generate a corpus. All right. We have the patterns here. Let's see. Let me copy these prompts first so everyone can do it with me. I will put it on the chat. Next, different patterns on Python. Okay, let's continue. This is our corpus of these patterns. And let's see. Let's attribute it so to save it on a file so we can try it on the same corpus dataset over and over. Put the generated corpus dataset set on file a file. See this pattern, and we can write on the corpus.txt. Let's just copy this code. And let me copy this first. So go on the chat. Okay, after it's after it's run, so we can start making the model of RNN. With this dataset we just created, as of it will be available in this files and the corpus dataset. It is just filled with randomized, same with this basically. And let's see if our data model can learn from it and create a language model. From this, mm, make a language model from our created, yeah, corpus dataset. So we are going to use our just created file to make a language model. Let's see. Let me copy this code first. And after that, we will close this and this. Run our code. So it will read the and the amount of sequence length is 40, amount of step 3. This is the hyperparameters we are going to use. And there are going to be an error. Let me see. Let's just copy this. And copy this error message and add it. Let me give some context on the location of the error and this part. Oh, it's going only change this row. See, Oh, it's only changing the NP pool to boolean type. So error on the Y. Let me remove this also. Hope let's hope it will run. Oh, this one has 20 box. Uh, Let me change it to 10 because this our dataset is not that complex and pretty simple. So maybe we can change it to uh 10 box only. All right. Uh, this one is currently training. Maybe if we can change our runtime type to T4 GPU. Let's see if it's going to be better. Let's change our runtime, hoping it will be faster. Let me, while waiting for that, I can copy the prompt to the chat. This is the prompt, and after that, act along with model. Oh, we're already doing that. I pasted that. This is only the error. I hope if everything doesn't run smoothly or throws an error, you can always ask ChatGPT like what I just did before by pointing out the error and some context of the error. Let's see. We don't have the files, so I have to run it from above again. Is it using T4? Yes. So the same. Let's run it again. Creating file and training the model. Let's see. It's definitely faster. So use the GPU every time you can. Okay. So for this language model we just trained, uh, we have a syntax of the quick run jumps over the let me close this first. It's supposed to complete the language model. So jumps over the continuous should be a lazy dog. On this string, we have to we will create it is creating character mappings for our characters and factorize the sequences and building model. On generate text, we will have a function of the model we are using, the seed text, the initial text we are going to have, next chars, and it will create a prediction of next characters. Uh, but we get, and the result is not that good over this one. After is kind of bad. Maybe because it is using characters. Let's ask ChatGPT to use in words instead. Use tokenization on the words instead of characters. See, let's check our newly generated code. before we run, let me change uh the epochs first, so it's not too high. Let's see. Training the model. Oh, this one will took longer. This accuracy is gradually become better and lost have smaller loss and bigger accuracy. I saw an error on this line. Let's see. The model is already trained, but the net function throws an error. So we can just do the same thing. Just copy this line to show ChatGPT where the error lies and the error message. This is the new generate text function because our model is already been trained, and but the error is only this line. We can just put the code for new function to generate text and run it. All right. Uh, this one is definitely better. On this, we can see the quick brown box. The quick brown fox jumps over the lazy dog, and able to finish the sentence. But after that, it will just predict the best word it can find to fill in the rest of the sentence. On this, we are using 10 next words. So it will do a 10 words after our C text or initial text. Let's see. Uh, Let me paste the code first, the prompters on the file, and this, and uh, ask ChatGPT to, eh, let me use the prompt to ask ChatGPT so we can see the uh accuracy. Write a code to check our model accuracy. While we wait on that, maybe we can try on a different word with different syntax. Uh, what sentence we're having is like better pepper. Let's see if it will complete the rest of the sentence. That's not it. All right. Uh, it's quite good for completing sentences that are in our original datasets, and because we are using such a small patterns or dataset, is not that good for completing the rest of uh, words, and just it was just using already uh, presented on these patterns. Let's see ChatGPT again to see the hmm, validation dataset, but we don't have validation dataset. We are using validation corpus. Let's see. I don't have validation corpus.txt. See, corpus. Oh, it will. This one will split the corpus or corpus to train corpus and validation corpus. Uh, we'll wait. I will put the prompt on the chat. Press C and say I don't have the validation if it's using validation corpus.txt. Ah, all right, it's finished. Uh, Training the new train data set, and on this one, we have accuracy of 97.9%. Is quite good for this model. I'm sorry. For this one, uh, it is using the LSTM, and the other one you can use is GRU. ChatGPT give us LSTM ones, and let me SGPT. So uh, create the one with GRU. Uh, sorry, you write Python code to implement GRU on the same corpus dataset and compare it with uh, previous, what was to say, the previous model. It is LSTM. Let's see. Using the corpus txt and tokenizer. Tokenizer is will tokenize each word we have to a single number. Let me see if it's better to use uh, LSTM or GRU. It's always based on the dataset we are using. So some dataset maybe is better with LSTM, or while some others is can be better to train with GRU. On this one is training the GRU model, and let's see while it compares. So training. While maybe ah, all right, it's already finished. On this specific data set, it is probably around the same for accuracy, but LSTM is slightly better. But the loss on LSTM still bigger than GRU validation loss. So use it on accordingly on the dataset you're using. But on the real application, we are not going to use the simple patterns. You can always ask ChatGPT to let me see, to use an even larger data set. You can always use something like the ones from Shakespeare's. Let me see if I can prompt. We can prompt it to use Shakespeare's works. Use Shake. How do you spell it? Here's. I hope ChatGPT can understand the context. Shakespeare's dataset. Wait. Works for the dataset. Ah, okay. I promise it. Right. Uh, Let me see. They are using GRU. So let me scroll down and This thing is splitting our train dataset, so we can always validate our model. But on this scale, let me see the amount of on this amount of text. It will probably take a long time, especially if you have not a very good machines. Ah, my session is crash on while trying to uh train on this dataset. So I hope everyone can try if on their own machines, like I have shown you before on last week, or use the uh what's it use the websites like before to train the models. uh it has various uh, types of model we can train. uh let's just and I hope everyone can try and do it yourself on yourself and on the largest data set, because on Google Colab is not very that good on using on the larger data set. Besides this data set, we can also use the besides Shakespeare's. Uh, there's probably a lot of language corpus, like let me see, uh, language corpus and set for internet. Mm. There are many. Let's see if we're not using for internet. Maybe like this one, full text corpus data. This one has about 2 to 10 million words. So obviously we have to use more epochs or configure the best epochs for this. But on the larger dataset, we will use this kind of datasets with millions of words. So our model is better. Uh, on this last one, let's see if ChatGPT can compare between this uh, implementations of RNN. Uh, let's see ChatGPT. Is it? Let me check on the chat if the prompt already there. Oh, let me copy this prompt first and the rest. So first, and this is the Shakespeare's, and as a ChatGPT to check the difference between what's the difference between LSTM and GRU. All right. Mostly on the architecture, while STM have three gates, input gates, for gate gates and output gates, and GRU have only two gates, and it is the update gate and reset gate, and member cell, complexity, performance, as were just tried before about the performance. Okay, maybe that's all for today's practical session of RNN.
Thank
Thank you,
you.
everyone.
Thank you, Jesse. Please practice your vanilla RNN, and LSTM and GRU will be explained next week. there is two biggest problem that LSTM and GRU solve compared to vanilla RNN, which is the first one is vanishing gradient. Sometimes if you train with RNN, the gradient is vanished. The network is not trained anymore. And the second one is overfitting. So that is a common problem that we found before historically, because I start learning RNN from vanilla. So we are very frustrated with those two problems. But those two problems is rarely found in LSTM and GRU. But LSTM and GRU is comparable in terms of performance, speed of computation, but sometimes depend on your data and patterns inside the data. Sometimes GRU win in terms of classification result. Sometimes LSTM is the winner. So usually we test the data with these two models and see which one is better for our data. Okay, let's learn more about LSTM and GRU and other modern recurrent neural nets next week. And the following weeks, we learn about attention and transformer as the basis of large language model that we currently use.